Hey, so I just graded the test and posted all those. I wanted to go over a few things moving forward so that, well, some of these you're going to have to use for the final and mastering chemistry and stuff going forward. So uh, let's go over some of the answers and some of the questions that a lot of people missed. So, what did I do? There it is. All right. So bowl of cereal. Most everybody got that one. Ethanol. So remember, if there's not more than one substance, then it can't be a mixture. Okay. So it can be. In this case, it has multiple elements. It has carbon, hydrogen, oxygen. So it has multiple elements. It can't be that. But it doesn't have anything except for ethanol, so it can't be a mixture. It has to be a compound. Um, the electron is negatively charged. I think you'll be able to go in and see the answers. So significant figures is something that we're definitely going to need to look at. Most people miss this, and I was trying to figure out why, and I think it is because of the way the text sets it up. So it talks about the decimal places. That's not the best way to look at it. So I will do a couple little things right here. When you are adding and subtracting significant figures, okay. So the question was 172.63 plus 340 plus 12.2. Okay, so 3, 8, 4, 2, 1, 5, 524.83 will be my final answer. And now, in order to determine significant figures, when you're multiplying, you just count whichever has the least number of significant figures. In that case, it would be this one, which has 2 significant figures. So our final answer would have 2. When you're adding, you need to look for the highest least significant figure. So let me show you what that means. The 4 here is the least significant figure in that one. The 3 and the 2. So essentially you're going to the last, I keep saying least, last significant figure. All right, and whichever is the furthest that way is the one that you're going to use. Okay, in addition and subtraction. So my last significant figure is in the 10 spot. All right, so then my last significant figure, my answer needs to be in the 10 spot. Thus, your answer will be 520. And I think most people put, and that's why I did this particular number, because some people wanted to go up to 525, all right, and have 3 significant figures. Others left the 8 there. But what you should have done was just leave the 520, 2 significant figures, but not because the least has 2. It's because the tens is the last significant figure. Let me show you another example. So you see, so in this case, let's say I have 1,000 plus 100 plus 10 plus 1. Okay? So what I'm looking for is the significant figure, the last significant figure furthest to the left. All right? So in this case, it'll be the 1 in my 1,000. So when I add it up, it'll be 1,111. But if I wanted to leave it in the correct number of significant figures, it would still be 1,000. Okay, because I can only have one significant figure because of this one right here, and it has to be in the thousands place. All right. One more example. Let's say I have 1,000 plus 200 plus 1,600. Yeah, that'll be fine. Okay, so I'm looking for the last significant figure coming this way for each one. That would be this one here, be this one here, be this one here. Now then my last place would be in here. We added up 2,800, and that would be the answer because it's two significant figures. What the book does is do like the last decimal place. So if I have this and this, then it says I need to use the decimal place furthest to the left. But this also applies without the decimal. Just keep coming. If you have numbers in the millions or whatever, keep coming to the left, or either adjust the number with scientific notation so that it's in the decimal place. All right. So yeah, a lot of people miss that one. No worries though. Let's get back. People did good with scientific notation. So the volume one. So a rectangle. You know, if you want to find the volume of a rectangle, you multiply the length times the width times the height. So that's all you'll do here. 10 times 18 times 12. Actually, I'm going to put all my units in there because I want to see. I think some people messed up. They didn't understand about, so density can be expressed in two different ways. It can be expressed in grams per milliliter. It can also be expressed in grams per centimeter cubed. So if I do the math on this, let's see, 180 times 12. Would be 2,160. And that'd be a centimeter cubed, right? Because I got 3 centimeters. All right, so now if I want to find the density, which is 2.12 grams per centimeter cubed. All right, so here is a volume, here is a density. Remember the density triangle? Let me go over here. The DMV, right? So you want to multiply density times volume. Fill this out so y'all remember. Density times volume to figure out the mass. All right, so easy enough. I have my volume here, density here, just multiply them. And you get 4,579. Let me go back to the test. So you see here that she rounded. I actually messed my significant figures up. So 10 would be the least significant figure. Technically, I should only have one digit there, but no worries. So in the future, I am going to mark off a little bit for missing significant figures. So just make sure you pay attention to that. Well done, Miss Henson. All right, let's look at, so everybody did the temperature conversion, easy enough. Let's do this one here. So I think some people just got confused on how you add up these molar masses, okay? And what these numbers mean here. So let me pull this back out. I'm gonna write the equation here. So the mass of copper, how much mass of copper will be produced if there are 0.4 moles of silver nitrate and 0.2 moles of copper chloride. Now this is the limiting reagent problem, okay? So you can only have 0.2 moles of copper chloride, and then, well, for the silver nitrate, you would need to divide by 2, because if you'll see here, I have 2 moles of silver nitrate for every 1 mole of copper chloride. Okay, so divide 0.40 by 2. That means you actually have 0.2 moles of silver nitrate, 0.2 moles of copper chloride. You have the same amount of reactants, so that's not a problem. The only thing you would do is multiply the molar mass of copper nitrate times 0.2, right? So 0.20 moles is how much I can make of the copper nitrate. Nothing else is limiting. Now I need to determine the molar mass. So go through your periodic table. I have a periodic table. Hold on. Where is it at? Here it is. Okay, so copper nitrate is Cu, and I'll be writing these in on my pad while I show you here, has a molar mass of 63.546 grams per mole. All right, nitrogen 14. I'm just going to round those off because they're close enough. Oxygen 16. All right, so let's go back to our equation. All right, so notice here that I have a exponent 2 behind the nitrate. That means there's 2 full nitrates on there. So what that actually looks like is this. I have a copper, I have a nitrate over here, and I have a nitrate over here. Well, let's clear that. Let's just say it's like this. Copper, and then a nitrate over here, and then a nitrate over here. Okay, so there's actually 6 oxygens and 2 nitrogens along with the copper. So going back to here, times 6 oxygens, 2 nitrogens plus the copper. So that'll be 16 times 6 equals 96 plus 28, right? 96 plus 28 plus 63.546. 187.546. All right, then I just multiply that times the 0.2 moles that I have available of material, and you get 38, round off to 38 grams. All right, let me show you that why. So moles times grams per mole, moles cancel out, you get grams. Okay, and make sure, so on the question it says how much mass of copper, so it's asking you for whatever the unit for mass would be. So you should automatically think grams. I saw some people, I think they tried to leave it in moles. So pay attention to the question, make sure you're getting what they're asking for. Okay, let's see, let's keep going. Same thing with density here. Most people got that right. It's pretty straightforward, just 129 divided by 39, like the density triangle. So mass divided by volume will give you the density. So the positron, some people miss that. I think you just they might not have noticed a proton has mass, so it couldn't have been a proton. And then gamma ray has no charge, so it couldn't have been that. I pretty much got all these. What else did I want to say? Okay, so on the specific heat one, I set this up really easy for y'all as well. So specific heat equals what heat divided by. So let me write this down. 4.184 joules per gram Celsius equals the heat over the delta T, change in temperature, and the mass. Okay? And so that'll be our C and our gram when we fill those in. And that's all you needed to do for this problem. That's all you need to do for this problem. So this is the specific heat of water. This is the heat that is needed, and that's what the question is asking for. The delta T is found by subtracting the final temp from the initial temp, and then the mass is given. So it did random variables. Everybody had different numbers. Let me do what this one is right here. It is 24.1 grams. And the temperature change of 100 minus 32.98. Okay. I'm writing all this down on my little pad here, so I'll swap back over. Mass equals 24.1 grams. All right, so now remember 4.184 joules per gram Celsius equals, we're solving for X, which is Q, and then we just plug in here 24.1 grams, and then here temperature change will be 100 minus 32.98 equals 67.02 degrees Celsius. I didn't put that on there. All right. So the grams in degrees Celsius will all cancel when I move these over here. So 4.184 times 24.1 times 67.02. And then that'll be expressed in joules. Do my math here. 4.184 times 24.1 times 67.9. So then lowest number of significant figures will be 3. 6,760. Wait. Yeah, that's right. 6,760 joules. Let's check it. She got it right. My equations are wrong, so I added the points if you got it right. There was a typo in one of my equations, and it didn't figure out right for the answer key. But I went back and I checked. I checked it myself. Okay. So fission. So remember, when two nuclei combine, it's fusion. When they split, it's fission. And when they bounce into other ones and cause them to react, that's a chain reaction. All right. So this question I just added as bonus. What I wanted you to do was try to fill in the coefficients. I saw every kind of answer. I had some instructions there that I thought were supposed to show up, but they didn't. I guess they were under the hints, which I didn't allow. So that's my fault. Like I said, it's bonus. If you figured it out, good job. We'll be doing some more of this tomorrow when we start going into chapter 8, because I want to make sure we get this right. But that's it for tonight. So I'll see y'all in the morning.